Now that we know how to prove triangles congruent, we're going to use those congruent triangles in order to write proofs about congruent line segments and congruent angles. So the little introduction here on this page says that remember that anytime you have two triangles that are congruent to each other, that means that all of their corresponding sides have to be congruent and all of their corresponding angles have to be congruent. In other words, in order to prove that we have two congruent line segments or two congruent angles, we can pick a pair of triangles that contain those line segments or the angles that we want to prove congruent, prove that the triangles are congruent, and then once we have congruent triangles, we know that the segments or angles have to be congruent because they're going to be corresponding parts of those congruent triangles. All right, so let's go ahead and see what this might look like in a proof, because I know you're dying to get to this part. Number one says, given angles 1 and 2 are congruent, which I can tell from the picture. Angles 3 and 4 are congruent, so I'm going to mark that. And they want us to prove, notice here that this is not proving a pair of triangles congruent, but rather we're trying to show that a pair of line segments is congruent. So I'm going to go find those in the picture. There's segment AD, there's segment DC. Those are the parts that we want to prove congruent. So our mission or our goal is going to be to prove a pair of triangles congruent that contain those line segments as sides. So a pair of triangles that contain those guys as sides would be the pair that I just highlighted in purple. And I'm hoping that you're seeing that this will be a fairly straightforward proof to write about. I need to talk about angle, side angle. And with that said, I'm going to go ahead and write this proof. So we're given that angles 1 and 2 are congruent. That's a pair of angles inside the triangles we want to prove congruent, so I'm going to mark that with an A. We're given that angles 3 and 4 are congruent. Those are a pair of angles within the triangles we want to make congruent. I'll mark that with an A. We know that's a true statement because it's given. We know that segment BD is congruent to itself by the reflexive property. That's a pair of sides inside the triangles we're trying to prove congruent, so I'll mark that with an S. And that is the reflexive property. And now we've talked about a pair of congruent angles, a pair of congruent sides, a second pair of congruent angles, so I can pull all three of those pieces together in order to make the conclusion that those triangles are congruent. So I'm going to say triangle BDA, and this is where I need to be really, really careful. Vertex B is the first one that I named. Vertex B is going to match up with itself, vertex B in the second triangle. The second vertex I named is vertex D, and vertex D is going to correspond or match up with vertex D in the second triangle. And the last vertex that I talked about here was vertex A. And angle A is going to correspond to or match up to C in the third triangle. So I have to be careful about the order in which I name these two triangles and be very careful to match up all their congruent parts. So that's angle, side angle. Now once these two triangles are congruent, I know all their corresponding sides have to be congruent. And it just so happens that side AD and side CD are corresponding parts of those triangles. So now I may go ahead and draw the conclusion that segment AD is congruent to segment CD. And the reason for that is anytime you have congruent triangles, their corresponding parts are congruent. Or in other words, corresponding parts of congruent triangles are congruent. Also known in the mathematical world as Cpctc. And that is the first and only time I'm going to write out corresponding parts of congruent triangles are congruent. From this point forward, I'm going to use Cpctc. All right, so really this is the same as we've been doing. Prove the triangles congruent. Once the triangles are congruent, we've got one more little step in there. at this point, if you have questions about the first example, please leave a note in the margin so that you'll remember to ask the next time that you come back to class. I'm going to go ahead and skip example 2 and example 3 on the next page. If you'd like, feel free to write proofs for those, and I'd be happy to check them when we see each other in class. But I'm going to go ahead now and shoot up to the top of the next page. Example 4 says line segment bisects angle ABC. Since line segment BD bisects angle ABC, I know an angle bisector is going to give me two congruent angles. So the first thing I'm going to do is go find angle ABC. There it is. I just color-coded it blue, and there are its two congruent parts. The next given says segment DB bisects angle ADC. So I'm going to go find segment or angle ADC. There it is. BD creates two congruent angles. There they are. So I can see pretty easy now I'm going to get those two triangles congruent by angle side angle once again. If we look at what it is we're trying to show congruent, we're trying to show a pair of angles are congruent. Well, angle A is an angle in the triangle on the left. Angle C is an angle in the triangle on the right. So once I get those two triangles congruent to each other by angle side angle, I can therefore go ahead and conclude that angles A and C are congruent by Cpctc. So now I know where I'm going to go with this. I'll go ahead and get my statements and reasons down. I'm going to go ahead and start with the first given. Segment BD bisects angle ABC. I know it's a true statement because it's given to me to be a true statement. Because that's an angle bisector, that makes angles 1 and 2 congruent to each other. And the reason for that, angle bisector makes two congruent angles. My next given talked about segment DB bisecting angle ADC. I know that's a true statement because it's given to me to be a true statement. And that, in turn, is what told me or allowed me to conclude that these two angles down at the bottom of the triangles, 3 and 4, are congruent. And that's because an angle bisector makes two congruent angles. All right, so far now I've talked about one pair of congruent angles, two pairs of congruent angles. I still need to talk about this pair of congruent sides. Side BD congruent to itself by the reflexive property. Now lastly, now that I've got both pairs of angles and my pair of congruent sides, I can go ahead and say these triangles are congruent. Once again, I have to be very, very careful when I name them. The triangle on the left I'm going to call triangle BAD, but now that I've named that triangle, I have to be very careful to match up the parts. So angle B in the triangle on the left corresponds to angle B in the triangle on the right. Angle A in the triangle on the left corresponded to angle C in the triangle on the right, and angle D in the triangle on the left corresponds to angle D in the triangle on the right. So I want to call that triangle BCD, and that is by angle side angle using steps 2, 4, and 5. Lastly, now that all those two triangles are congruent, I know that all their corresponding parts are congruent. Well, the corresponding parts I wanted to prove congruent are angles A and C. So I may go ahead and draw the conclusion that those two angles are congruent. As for the reason why, I know that all corresponding parts of congruent triangles are themselves congruent, or Cpctc. Sometimes kids like to write congruent triangles have congruent corresponding parts. Or in this particular case, we could say congruent corresponding angles because we're talking about angles A and C. All right, folks, that's all I have for you today. As always, thank you for the gift of your time. If you do have questions, please do leave yourself a note so that you can remember to ask them the next time that you come to class. Till then, make it a good one.